This is a truck starter rotor. Its insulation is weakened, so it no longer works properly. In many places, it would only be sold as scrap metal. But in Pakistan, for only 2,000 rupees, it can be restored like new. After removing the commutator, the worker starts removing the rotor coils. You can clearly see the copper bars are badly corroded, so the worker fully disassembles the rotor and heats it with a torch for annealing. At the same time, impurities are removed. After annealing, he uses diluted sulfuric acid to dissolve the copper oxide on the surface of the copper bars. The reaction happens very quickly. In just a few seconds, the blackened copper bars become shiny and clean again. Next, he polishes the copper bar ends with a grinder. Because copper reacts with oxygen, an oxide layer forms on the surface, so it must be removed. After polishing the ends, the rotor is placed on a lathe. Sandpaper is used to remove rust from the steel laminations. After cleaning, new insulation sheets are installed. These insulation sheets are handmade by the workers. To speed things up, another worker cuts insulation paper. The quality of insulation work is also a key sign of the worker's skill. Each slot in the rotor laminations must be fitted with insulation paper. The worker measures the paper width in advance and folds it before inserting it. The length must also match, and extra parts are trimmed off. Next, the restored copper bars are inserted back into the rotor slots. Before insulation, each copper bar is straightened first. To make insertion easier, a copper bar is used to open the insulation slots. Inserting the bars is fairly simple. Since their shapes were corrected earlier, the worker only needs to insert them in order. To prevent short circuits between bars, their spacing must be adjusted carefully. Also, to ensure the exposed parts do not touch, the worker uses another type of insulation paper and cuts a longer strip. The strip is threaded through the gaps to fully separate the upper and lower copper bars. After placing the insulation paper, the copper bars are pressed back into place. Halfway in, the worker taps them lightly with a hammer to adjust the position. To ensure good long-term performance, the bars must be fully seated. To make sure everything is correct, the worker performs a continuity test before installing the commutator. After confirming no issues, he skillfully uses pliers to reshape all the copper bar ends. The goal is to fit the commutator properly. The angles must also stay balanced without causing short circuits. The ends of the upper and lower bars must tilt evenly to both sides. Later, the worker needs no tools and shapes them perfectly by hand. Now the commutator is polished and the carbon slots are cleaned. Then the commutator is driven onto the shaft. After adjusting the position, all the copper bar ends are pressed into the welding slots. Because the angles were adjusted well earlier, installation becomes much easier. To place insulation paper more easily, the paper is inserted first, before fitting the second layer. This is a trick learned from years of repair work. Then the second layer is hammered into place. The ends inside the welding slots must be tightened as much as possible. Starter motors work under harsh conditions and strong vibration. A tighter fit makes the welds stronger. Otherwise, the welds may loosen later. Again, to ensure everything is safe, before welding, the worker performs another test. Since there is no soldering iron, he heats a metal plate and uses it as a soldering tool. Where there's a will, there's always a way. Judging from the final result, the welds look very solid. After welding, the rotor is placed on the lathe again and polished with sandpaper. Because the welding process may cause solder bridges, which can affect the commutator, so another round of polishing is needed. After polishing, the worker uses a knife to clean the gaps in the commutator. To prevent loose bars and movement, he tightly wraps the copper bars with nylon cord. Finally, insulating varnish is applied to both ends of the rotor. This improves insulation while also making it waterproof, moisture-proof, shock-resistant, and more durable.